Okay, we're in section 4.3 of the homework. Again, I can't remind you enough about the importance of you doing homework outside the class. And the more time and effort you put into your studies, the more likely you'll be able to do very well in exams and move forward in your studies and hopefully enter a career that you enjoy. All right. Now, again, if you're doing things you don't enjoy, you really want to reconsider what your major is by trying to find something that I'm not going to say totally love, but at least you're not dreading it, right? You're not putting it off to the last minute to do things. All right. That you find some pleasure in doing this. So I'm going to say over here, I'm going to do these problems over here. The blue area does give me some indication that there is an answer to the problem. I can't look at that and say, oh, yeah, that's right, without reading the problem, but I'll go through the steps involved and we'll do, there's not many problems here, and this shouldn't really take much time to do. All right. Now, by the way, it would take an infinite amount of time if you had no understanding what you're doing because you couldn't do anything. But if you have an understanding, you've attended lecture, you paid attention, and you're capable of doing simple things, then these problems should go very smoothly and quickly. All right. Let me switch the screen. I'm going to go to the whiteboard now. And again, we'll do one thing at a time. And my understanding about these problems over here is that, one thing I could say, oh, yeah, there's the answer. It's got to be right. No, I got to do the problem. And my understanding over here is I'll read it to you. It says, find the volume V of the solid whose base is the region enclosed by. Well, let me put this down for you. And the first thing I do is I got to visualize what the base looks like. And the base is going to be a curve, really simple one. I'm glad for that. This is the first problem, by the way. You'd expect something simple. That's the curve y equals x squared. Then they got y equals 3. This is y equals 3. And this is the base of it. Let me just shade that in for you. And this is the base. By the way, a base is an area. Right, so I got that covered. That's not a big deal. Then they go on to say whose cross section perpendicular to the y-axis are squares. Let me see if I can visualize that. And what I mean by that is I'm going to draw a perpendicular, like something like this over here. So what did I just draw there? I drew a rectangle, right? But now I got to visualize what the square would look like. And what would the square look like? Well, it would look like it would have this, right? You see that? And then I'll do something like this over here. And that looks like a box to me now. Right, that's a box. Wow, what's a differential? The differential is dy. So I'm going to write that down for you. All right. So the y's are moving from 0 to 3. The differential is dy. What I have to do, though, this is the dy now. I got to figure out what's the dimension of that square. Because a box is pretty easy to volume, right? It's the thickness times the surface area of the top. It's pretty simple to do, right? I got to do that now. And I got to figure that out. So remember, I'm looking at y. This is like an edge over here. And this is an edge over here. And that's y is equal to x squared, right? Okay. So I got to figure this thing out over here. Well, this corresponds to the x, doesn't it? So what's x over here? X is equal to the root of y over here. And what's the x over here equal to? X would equal minus the root of y over here. So what's the total distance over there? It would be 2 root y's. What's this dimension? Well, they said they're squares. So this is 2 root y. All right. So what's the volume of that box? 2 root y times 2 root y times dy. And write that down for you. Let's do our integrations. What's the first step in my integration? I got to simplify that guy. 0 to 3. I'd like to pull a constant out. That would be y squared dy. I'm sorry, not y squared. I'm dreaming. Actually, I'm thinking about something else. I got my eraser out. That has to go. Okay. So you get, I did it again. Made another mistake. This is not 2, that's 4. We got an answer. Look at it later. So 2 times 2 is 4. Root y times root y is y. What I'm going to do now, antiderivative. What's it going to be? Y squared. 2 on bottom, so it's 2y squared. 0 to 3. Y, it's a nice, easy problem. What's that going to give you? 2 times 9 is 18. What's that going to be? 18 cubic units. Let's look at our answer. See how we did. Wow, got that one right. All right. Let's do the next one. Average value of the function. Couldn't be easier. I'll write this down for you. Again, you would need to know that. I'll write this over your F average. It's going to equal 1 over, we're doing problem number 2 now. 4 minus 0, 0 to 4, x cubed dx. Gee, that's a gift problem. 1/4. That would be x4 over 4, 0 to 4. Well, let's see, that's going to be x4 over 4 squared, 0 to 4. I really mean it's a gift problem. If I did it right, it's a gift problem. So let's see, you'd get 4 to the 4 of 4 squared, which would be 4 squared, minus 0, which is 16. All right, let's go to the next page, see how we did. And what I mean by that, wow, 16. No problem there. Calculate the average over the given interval. Another gift problem. Let's take a look. So I'll put this one over your FAV is equal to, whoops, I went a little too quick there. 1 over upper 1 minus a minus 1, which is plus 1. Limits integration minus 1 to 1. 1 over, I guess that's x squared plus 1, right? Dx. It's going to be 1/2. We'll look at the key later. Do I know the answer to that? I do. It's arctangent of x, and the limits of integration are minus 1 to 1. This is 1/2. Well, the arctan of 1 is pi over 4. Minus the arctan of minus 1 is minus pi over 4. Oops. And what do you get over there? 1/2. This would be 2 pi over 4, which is pi over 2. And this would be pi over 4. Let me see if I did it right before I go any further. That would be pi plus pi, 2 pi over 4. That's a 4. Pi over 2. Yeah, pi over 4. Wow, miracle. All right, really easy problem set. All right, what I mean by that, the problems really flowed very nicely. You should know average value, and you should know the area of boxy-like structures. Okay, thank you.